In this video, we're going to take a look at the idea of concentration. If you recall from the previous video, we focused a lot on the concentration, more so in terms of household products or things that are more common for lay people. We're going to look here at concentration, but very specifically as to how chemists might report concentration. So the first thing is to take a note that when we're talking about the concentration from a chemistry point of view, we're very often talking about the moles per liter. And we call this the molarity. And so we'll talk about the molarity of a solution being the number of moles of solute in the volume of the solution. So moles per liter. It's such a common unit that we actually abbreviate it to just a capital M for moles per liter. An example of this would simply just be if you're told there are this many moles and the volume of your solution is this much. And then you can do a little bit of a quick calculation to determine the number of moles per liter. So we could say, for example, let's say you're given 1.5 moles of sodium chloride in a volume of 500 milliliters. So that's the volume of the container. There's a 500 milliliter container and it's full and it has 1.5 moles of sodium chloride in it. Let's assume that that's 500 milliliters to three significant figures. So the problem here is that while you have the number of moles, and this is good, we don't actually have the number of liters. What we do have is the volume in milliliters. So we need to start by converting this. So I would say 0.500 liters. Now that we have everything in the right units, we've confirmed what we have, we can calculate the concentration by saying it's the number of moles, which has the symbol N, not the unit MOL, the symbol N, and volume has the symbol V. So we can say that the concentration of the solution is 1.5 moles in 0.500 liters, which leaves us to a 3.0 mole per liter solution, or you might sometimes see it written like 3.0 with a capital M for molarity or moles per liter. A problem arises though if you're not given the number of moles directly. Let's say that in a different example, instead of giving you the number of moles of sodium chloride, what I'm going to give you is the mass of sodium chloride. So here I'm going to tell you that you have 3.5 grams of sodium chloride, and I'm going to say that the volume of the solution, just to be a little bit different, is 1.50 liters. So like last time, we have one thing that is correct. In this case, it's liters. Before it was the moles. But this grams isn't quite right because my equation is moles per liter, not grams per liter. So I have to do something with this grams. Well, thankfully, I remember that I can convert from grams to moles. I convert from grams to moles by going through the molar mass. So you would have to check out the molar mass of sodium chloride. So you would take the number of grams, 3.5 grams, and you would divide by the molar mass. The molar mass of sodium chloride is about 58.44 grams per mole, which leaves us with 0.060 moles. Now that I have this value, I can make use of it in my concentration formula. It's going to be the exact same one as before because now I have the correct value. So I'm going to say here that the concentration, C equals N over V, means that N is what I just calculated, 0.060 moles. V was given to me in the question, and that's going to leave me with 0.040 moles per liter. However, if you want to write it in scientific notation, you would say 0.4 times 10 to the negative 2 moles per liter, or capital M for molarity. Just like many of the other problems we've done, we don't necessarily have to look for the variable at the start of the equation. So I don't necessarily have to ask you to solve for concentration. You could solve for the number of moles. So for example, if you're given a problem where you know the concentration of the solution, so maybe I'm going to say you want to make a solution that has a concentration of 0.50 moles per liter, and I want that solution to have a volume of 250 milliliters. So now the question becomes, how much solute do you need to add to that solution? Well, you should first identify the fact that our volume is incorrect. It's not incorrect, but it's not in the right format. So we'd have to change this to 0.250 liters. I'm just assuming that it's 3 significant figures there. If you look at our original equation, which was C equals N over V, you might be able to pick out right away that if I multiply both sides by V, I can rewrite this equation as N for number of moles is equal to CV. So to get the number of moles, all I have to do is multiply the concentration, which was given to me in the question, by the volume. And if you look closely, you'll see that the liters are going to cancel here, and you're left with moles, which is the correct unit that I want. Right? The question is asking here how many moles of whatever substance are required to make this particular solution. So this leaves us with the number of moles of 0.125 moles of whatever solution it is you're looking for. Finally, we can take that one step further and we can use it to solve for the number Now, we could take this one step further and solve for the number of grams, or whatever mass unit you want, that this solution might be made out of. So it doesn't matter what chemical you pick. We're going to pick sodium hydroxide because it has a pretty easy molar mass. So if I wanted you to then take this number from our just solved question, and I would then ask you something along the lines of maybe how many grams, or maybe what mass of sodium hydroxide is needed to make 250 milliliters of a 0.50 moles per liter solution. So we've already solved the number of moles, right? Because I'm using the same numbers as before. All we're going to then do here is take the value that we just came up with. So we did our C equals N over V, but we solved for N instead. And to get to the mass, because we have ability to weigh mass, we don't have ability really to effectively weigh number of moles. So to weigh the mass, or to determine the mass, you just have to recall that the mass is equal to the number of moles times the molar mass. So I'm going to take my number of moles from the calculation I just completed, and I'm going to multiply by the molar mass of sodium hydroxide, which is 40 grams per mole. And if you look at this, you should see how my units are going to cancel out again. So you can see right away, hopefully, that we have moles here, and we're left with grams. And so this tells me that 5 grams of sodium hydroxide is 0.125 moles. And if I put that into 250 milliliters of, let's say, water, I would produce a 0.50 mole per liter solution of sodium hydroxide in water.